Hi everyone, this is Mr. D from Mr. D Math working with Bridgeway Academy, and this is the math you need to know. This time in this video we're going to be looking at surds, the unpredictable numbers. So what is a surd? Well, if you see on the screen you might notice that number 3.14159,265 and on and on and on. You may know that number, and you may know that number as pi. So does that mean that pi is a surd? Well, we're going to find out. So let's talk about what a surd is. Simply said, a surd is an irrational number. Now you may be saying, well, what is an irrational number? Well, that's a great question. An irrational number, let's see. Well, before we get into what an irrational number is, or a surd, let's come back to that and start with where numbers began. I say that numbers began with counting numbers, and counting numbers began at the number 1. Just think if you looked up into the corner of your room and I said, count something for me, the number of light switches in your room, maybe the number of keys on your keychain, and you would start and you'd say 1, 2, 3. You wouldn't start at 0, you wouldn't start at 3.5, you'd start at 1. We call these counting numbers, where they began starting at 1, the natural numbers. Why? Because it's natural to start at 1. So here they are, 1, 2, 3, 4, 5, and so on and so on and so on. And if you notice the ... right here, that ... just means they keep on going and going. So we gave them a really cool name. We called them the natural numbers. Why natural? Because it's natural to start counting at 1 when you're counting things. But then someone figured out that you could have less than 1 and created the idea of 0. That gave us the natural numbers, 1, 2, 3, 4, 5, on and on, plus 0, and that got a cool new name itself called the whole numbers. So the whole numbers start at 0, 1, 2, 3, 4, 5, 6, ... It's all the natural numbers plus 0. Well then, someone figured out that you could have less than 0, and they created the idea of negative counting numbers. So let's take all the natural numbers plus the whole numbers, which just means we're adding 0 to the positive counting numbers plus the negative counting numbers. Then we have integers. But then someone figured out that there were numbers in between all the counting numbers. We call all the numbers in between the counting numbers fractions and decimals. And you might be saying, well, I knew that. Well, check this out. When you have a fraction that can be written as a ratio of two integers, we call those rational numbers. I'm going to say more about that in just a moment. And any fraction that can be not written as a ratio of two integers, we call those irrational numbers. Another way to say that is the surds. There they are. Wait a minute, what? How can something be irrational, or AKA a surd? AKA means also known as what? A surd. Well, let's just look at the difference between rational and irrational numbers. You got the long, kind of boring definition. Let's get you a definition that works. So what's the difference between rational and irrational numbers? Well, rational means they're predictable, and irrational means they're unpredictable. Well, what does that mean, predictable and unpredictable? Well, let's find out. You see, in math, when something's rational, that just means that you know what the next number is in a decimal, or you can write that number as a fraction of two integers. I'll give you an example. 3 over 4 is a rational number because I used an integer, 3 over 4. I could even say 4 over 3. It's still rational because I wrote it as two integers, the integer 4 over the integer 3. So what's not going to work out? Well, if I did something like this, the square root of 7 over 3, that we can't use, and we're going to come back to that square root of 7 in just a moment. Think about this fraction, 1/3. It's rational because it can be written as a fraction of two integers and as a decimal. It's predictable. You can predict what's coming next. You see 0.3 with a little bar over it means it's a repeating decimal, which goes like this, 0.33333. Can you predict what's coming next? What's going to go right here? I'm sure you guessed it already, a 3. But pi, well, that's an irrational number. Why is that irrational? Or another word for irrational is it's a surd. An irrational number is just another word for surd. Or surd is just another word for irrational numbers. Depends which word you heard first, doesn't it? So check it out. Pi is irrational. Why? Well, it can't be written as a fraction of two integers. We try, but we just can't do it. So what comes next in the decimal? It comes right here. I don't know. Do you know? You might say, well, I learned it out a few decimal places. Well, we don't know what comes next. Because we don't know what comes next, that makes it irrational. Because it's irrational, pi is what we call a surd. That's why we say surds are the unpredictable numbers. So what does come next? What makes it irrational? What makes it unpredictable? What makes it a surd? So what does come next? Well, we don't know. That's why it's irrational. That's why it's unpredictable. That's why it's a surd. S-U-R-D. I know you were wondering what comes next. Well, here's what comes next. Pi is approximately, and notice here, approximately, because it's not exactly, because there's more. 3.141592653588793, on and on and on. Scientists are still trying to figure out, where does pi end? So when I said it was 3.14159, what came next? And you could say a 2, but what comes after that? Well, then a 6, and then what? Well, on and on and on. And you'd have to keep looking on this chart, or you'd have to know it yourself. But it keeps on going even when we get down here to dot, dot, dot. We don't know what comes after this 2. So now we're going to look at square roots. The square root of 12, and if you haven't seen this symbol before, it just means the square root of 12. Think of the square root of 25. You might know that, and most people say, well, I know the square root of 25 is 5 because 5 times 5 equals 25. By the way, you can watch another video on the math you need to know about square roots to find out more about how this works. But if you think about 25 like a perfect square, the square root of 25 equals 5 because 5 times 5 is equal to 25. So we say the square root of 25 is 5. But the square root of 12, well, there's no number times itself that makes 12, so it's irrational. We can't write it as a fraction of two integers, and we don't know what's coming next in the decimal. Check it out. What comes after the 4? We don't know. So let's take a look at my handy dandy calculator here. And when I go and turn on my calculator, I'm going to put in the square root of 12. Watch how this looks as I click my square root button and I put in the 12. And I say, well, what is the square root of 12? Well, there it is, 3.64. What comes after that is a 1. After that is 0, and then a 1 and a 6 and a 5. And out here at the 5, even the calculator rounded it off. I don't know if it's really a 5. Maybe it's a 4. The next number is a 9, and the calculator rounded it. It's irrational because they don't know what's coming next. So now you know that the surds are the unpredictable numbers, the irrational numbers. But let's put it all together so you get the whole picture. Surds are just a piece of the puzzle. Natural numbers, the positive counting numbers. Whole numbers, the positive counting numbers, and 0. Integers, the negative and positive counting numbers, and 0. Rational numbers, any number that can be written as a fraction or any number that can be written as a repeating or terminating decimal. What I want you to remember is rational numbers are predictable. You know what's coming next. By the way, repeating or terminating decimals, let's take a look at that. What does that mean? We saw repeating decimals already, but what happens when something's terminating? The word terminate means to stop. So a terminating decimal stops like 4.25 or 4 25/100ths. So why is it predictable? Well, because you know that the next number after the 5 would be 0. And what if I wanted to put the number after that? Well, you could put another 0, and after that, another 0, and after that, another 0. It's predictable. I know what's coming next. I could put as many zeros as I like. Dot, dot, dot. Keep on going. But what's happening is that 0 keeps repeating over and over again. That makes it predictable. That makes it rational. Are irrational numbers any number that's a non-terminating, non-repeating decimal? They are unpredictable. And if it's irrational, what do we call it? You've got it now. Irrational numbers are what we call surds. There they are. The surds, the unpredictable numbers. Why did I say that? Because now you know that they're unpredictable. You don't know what's coming next. Now you've got it, and you can tell your friends. Irrational numbers are also called surds. So since they're called surds, that means they are also the unpredictable numbers, which is why we called the surds the unpredictable numbers. What if we took all the numbers and put them all together? Well, we would get what we call real numbers. So the real numbers are any number that's natural, whole, integer, rational, or irrational, or you could say, or a surd. Wait a minute, that leads me to a question. Here's my question. We just talked about numbers when they're real. So what happens if they're not real? They must be what? What happens when numbers are not real? Believe it or not, there's actually a whole series of numbers that when they're not real, guess what we call them? Some of my students call them fake, but another way to say that is they are imaginary. And when you get to a course like my Algebra 2 course, you'll learn all about imaginary numbers. Let's do a little exercise and see how you're doing. We want to put an X in all that's true. Let's start with the number 12. If it's true, we'll put an X there. So is 12 a natural number? Was it a counting number that starts at 1 or greater? It is. It's a natural number. Is it a whole number? It is, because if it's natural, it's also whole. So we'll put an X there. Is it an integer? It is, because it's a positive or negative counting number or 0, so it works. Is it rational? Yes. Now watch this, because I can write 12 as a fraction. So yes, but remember, numbers are either rational or they're irrational, and I'm going to write surd here because we also mean that it could be a surd. So watch what's going to happen. If I put an X here, no X goes here. And it's also a real number because it could be a natural, whole, integer, and rational, so that makes it real. How about negative 12? Well, negative 12 can't be a natural number because it's negative. Can't be a whole number because it's negative. But it can be an integer because an integer is a positive or negative counting number or 0. Is it rational? Yes, because I can write that as a fraction, or I can write this. Watch this. What if I said negative 12? What comes after the decimal? 0, and that's fine as well. More zeros, more zeros. So negative 12 is rational, so it's not irrational. It's not a surd, but it is real. The square root of 12, well, we already talked about that. It's not natural. It's not a whole number. It's not an integer. It's not a counting number. So it's not rational either because we can't make it into a fraction of two integers. So now it's a surd, or what we mean irrational, but it's still real. Let's look at 2/5. Is it natural? No. Is it a whole number? No. Is it an integer? No. Is it one of those numbers that's in between all the integers? Yes. And we can write it as a decimal that either terminates or repeats. We can write it as 0.4. Then you can start adding zeros after that. So it's predictable. So it's not a surd, it's not irrational, but it is real. How about 0? Well, look at 0. 0's not natural. Doesn't start at 1 or higher. But it is whole because that's when it became part of the counting numbers. It now became a 0, 1, 2, 3, 4, 5. It's also an integer. Now this looks kind of crazy. Can you make 0 into a rational number? Sure, you could say 0 over 4, which still equals 0. You could say 0 point what? 0, what comes after that? 0, 0, 0, on and on and on. So it's rational, which means it's not a surd, but it is real. Hey, they're all going to be real. Go check that out. Negative 5/6, well, negative 5/6 is going to just be the same as 2/5 in terms of the kind of number it is. So it's not natural, it's not whole, it's not an integer, it is rational. It's not irrational, but it is real. It's okay if fractions are negative. And this one you could write out as a repeating decimal if you wanted to try it on your calculator. Then we go to the square root of 73. Well, think about your perfect squares. If I started counting my squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. There's nothing that I know that's going to give me a 73. So it's none of my natural whole integer rational, but it is a surd. Hello, surd. There we go. We've got the square root of 12 and the square root of 73. Surds are irrational, which are still real numbers. Watch this one. This last one, it's tricky. Why? Because what do we know about the square root of 25? Well, the square root of 25 equals 5. Oh, now it's going to be like that number 12. It's a natural number. It's a whole number. It's an integer. It's rational, but not irrational. It's not a surd, but it is real. And there we go. You can practice these numbers as well. There's some practice problems that you can do. And to finish up, how about a nice chart that brings it all together? You can print this out too if you want to see the surds, where they are. Well, here they are. The surds are numbers like pi or the square root of 12. But if I take all of my rational numbers, which include what? Well, it includes all the natural numbers. It includes all the whole numbers, all the integers, as well then all of the fractions and decimals that are terminating or repeating. And I add to it all the irrational numbers, or surds, our new word of the day. Then I get what's called all of our real numbers. And there we go. Well, now you know what surds are and why we call them the unpredictable numbers. This is Mr. D, and this is the math you need to know. See you next time.